are like at a major inflection point since the start of this human civilization. So we have never really harnessed the real power of human intelligence. That's what I personally think. So with the technology, is AI technology or software automation, we are going to really make massive amounts of progress. And I think this AI or software automation or AI industrialization is going to expand into each and every industry possible. Yes, the AI. Hello, everyone. Welcome to Connecting Minds. I'm Dr. Viswanath M. Aluru. In this episode, we're going to continue with our previous conversation where we talked about quantum computing, quantum global quantum partnerships with NVIDIA CEO Jensen Huang. In this episode, this is another simulated dialogue with NVIDIA CEO Jensen Huang about what it really takes to actually run a AI data center. So, because AI infrastructure is not just about chips or cables, it's like an ecosystem that turns raw compute into world changing intelligence. Think of it as a neural network of digital age where the data centers act as the brain hubs interconnected globally for training massive models like those behind Grok. But building and running a data center is like a symphony of power, precision, and persistence. So, in this episode, we're going to break it down into various components, what it takes to actually run a global data center, in the words of NVIDIA CEO Jensen Huang, as evidenced by from the Grok. So the first component is the hardware. At the core of the hardware is just like the power. Uh, Accelerators like our Blackwell GPUs. Think rakes crammed with thousands of them, each sipping about 700 watts to 1000 watts per chip. A single supercluster might house 100,000 accelerators, demanding specialized servers optimized for parallel processing. So we're talking about TPUs, DGX systems. They're all wired with ultra low latency networks like 400 Gbps Ethernet to sync those GPUs without a hitch. So the next important component is the storage. So the scalable SSDs and NVMe's for petabyte of data zipping at lightning speeds without any bottlenecks when you're training models that crunch billions of parameters. And the software layers like CUDA orchestrate it all, making sure um, every cycle counts. Uh, the main fuel is the power itself. So, because these massive data centers they guzzle electricity like nothing else. So, a typical AI rig totally pulls about 40 to 120 kilowatts, and we are eyeing 250 to 1000 kilowatts per rig by 2029. For a full capacity, 100 megawatts to gigawatts, which is actually enough to light up to 75,000 homes or more. So the globally, the data centers they're already eating up to 1 to 1.5% of electricity, uh, tripling to 3 to 4.5% of electricity consumption by 2030 because of all this AI compute. So what are the redundant supplies that are needed, like utility feeds, on-site generators, UPS for critical loads? So maybe only 20% can be fully backed up to keep the costs low. So again, we have to push for sustainable sources of this power, like solar power, wind, even small modular reactors, or co-locating with nuclear plants to slash queues and go green. So The partners like Microsoft are investing up to 80 billions into expansions, and hyperscalers like NVIDIA, they're committing to up to 150 billions over 15 years. Um, Again, so there's a lot of wait times and can go up to 7 to 10 years even in terms of the power supply. So that's why it's important to innovate in terms of microgrids, higher voltages like 415-volt AC to cut the losses. Now, all that power, what happens is it's going to turn into heat. So the next important step in the AI component in AI infrastructure is the coolings, which is like an unsung hero. So the traditional air cooling systems are fine for 20 to 30 kilowatt racks, but the AI data centers pushing to 100 kilowatt plus, where the air really chokes. So that's why it's important to have the liquid cooling or direct to chip cooling with water loop seating 3500 times air efficiency, or immersion in dielectric fluids that boil off heat passively. So, for example, Google has been using liquid cooling TPU since 2018, and NVIDIA's GP200 um, thrives on this model as well. So the cooling itself eats away 40% of power. So the aim for PUE is under 1.2. So by reusing the heat for buildings or going chill free cool climates also is one of the important aspects of cooling. Uh, but innovations like rainwater harvesting is also another important steps in cooling process. Um, Another important component of AI data centers is networking and security, which tie together. So the high bandwidth fiber, 4 to 5 times more per rack for seamless GPU data. And also, security is very important. Layers of encryption, firewalls, AI-driven data monitoring to fend off any cyber threats. Modular designs let you scale hybrid crowd-style blending on-prem with edge for low latency real-time AI. The building process. So there needs to be a roadmap. We need to clearly define goals for building a AI data center, whether it is an automation or a model training. And we have to pick a site with power, cool climate, incentives, secure energy needs, implementing liquid cooling, optimizing network infrastructure, and plan for scalability. So timeline for building a AI data center is anywhere between 1 to 2 years per center, but for the grid upgrades, it can take anywhere between like 7 to 10 years. Um, Cost is astronomical, so it's up to 5 billion to build a 100K accelerated facility, and of course, so many more billions for the hardware. The hyperscalers are nearly eyeing 1 trillion in 3 years, with utilities adding another trillion for grids. But the return of investment is going to be massive in terms of like faster insights, automation that shapes the AI industrialization. Operations. Um, Again, we have to think about the chip losses. The demand is like 99.9% of time. AI analytics for predictive maintenance and workforce skills amid shortages. Environmental impact. So we're trying to mitigate with renewable energy, but again, the U.S. demand for power consumption could hit like 120 gigawatts by 2035. Again, there are several challenges like supply chain challenges, permits, etc. So again, there's a lot of innovation is going on in terms of like power or cooling systems or mitigating chip losses, all those things. It's about resilience, it's about vision. The AI data centers are not just the buildings, they're accelerators for humanity's next step. It's really mind-blowing how all these come together in order to build this AI ecosystem. And let's talk a little bit about the AI bubble. So this is like a multi-billion dollar question. And so are we actually in AI bubble? So this is my personal opinion. The way I look at it is like we first need to separate these AI hyperinflated valuations from the AI technology itself. Because if you look at this history of AI, it's not something that happened in the last few years. The technology of AI itself has been around for almost 40, 50 years. But of course, there are ups and downs. We did not have enough tools, all that's needed to harness the real power of AI. But now we're at a stage where we have all the tools that are needed. So I personally think the AI technology itself is going to stay. So it's almost like a software. I call it a software industrialization, or it's like a software automation, or software revolution, whatever you call it. I like to give the analogy of like an ice cream stand. When I was in my school days, it used to be like, ice cream cart where you go and buy like a pre-molded or pre-packaged ice cream, right? But what happened is with technology, we have these upgraded ice cream stands where you go, you order an ice cream, and they can mix different flavors, and they can make it into different molds or settings or shapes, and they can add toppings. They do everything in real time. So that's exactly what is happening with software and AI automation. So everything can be done in the real time, and adjustments can be made in everything in the real time. I myself did, vibe coding using AI platforms, several websites. So that's the difference. What we are seeing in terms of AI automation, software automation. So infrastructure needs are going to be astronomical, but the upside is that this AI industrialization is going to be massive, exponential. So I personally think that the companies that are actually working on AI infrastructure, okay, or advancing AI technology are going to be the most valuable companies in the future. So that's my personal opinion about um, are we in a bubble or not. I hope you all enjoyed this episode, and I will see you all again in next episode. Please do comment your thoughts on this episode, and thank you for joining me on Connecting Minds today. See you soon. Thank you.